Hello, hello, hello. Welcome back to a very rushed, last minute, getting ready, still trying to catch my breath stream. It's been a crazy day. Been trying to get a lot of the new things on this printer, sorted out in my head as to how I'm going to finalize and finish off, and between all the other work and a couple of other things happening, it was just one of those days. I'm glad to be streaming tonight. I think I'll be probably stumbling over my words as I am already. I'm trying to get some of this settings done, but you know what? We're going to go with a learning experience tonight, because what we've reached up to this point is pretty much, I would say, 90% stock standard of what RatRig would put in a kit and what you would build, although we've also gone overboard. But I'm talking in terms of electronics and setup and things like that. What we have now obviously included is things like the heaters that we're going to put inside and a couple of other features, but from a configuration perspective, we haven't really changed any configuration, and so tonight we just want to try and catch up on some of those items and see how much of it we can get done and see how much we can actually get set up. I did play around with the mesh from last week, and I've removed some of those settings again, so I can just show you what I've had to do to get the mesh just working properly. But yeah, I think that's it. Let's get going. You can see I got the fans on. Obviously I need the fans, both fans there for the Raspberry Pi and the let's move this slightly this way, then I can maybe show you to better. Yeah, there we go. So we've got both fans connected, and we can start playing. This wire hanging out here is a chamber temperature probe that I'm testing. I can't remember what the model numbers are of the probes, that are the thermistors that I have, and it's a bit of a guess. So I'm plugging in and out, and playing around a little bit with that earlier, although I didn't get to the end of it, so it's now just hanging there. We'll put it away later. I really want to get to the point where I've got the bed thermistor reading and that heated, that all lined up, and then I'm also going to possibly put some of the LED strips in on the next stream. But on the next stream I'm going to be covering all of these things up so that we don't have these little gaps all over, and then we'll get a better picture of what it's really going to look like when it's finished. Hopefully by that time as well I've had a replacement for this filament guide, because yeah, that didn't work. And you'll see there's this very strong piece of steel hanging over here, that fish tape. I've also got to find a better solution for the actual top end of the machine, where the cable loom that's going from the back to the printer head, it was stronger than I intended it to be. So I need to get half this weight type of a fish tape or something smaller. I tried spring wire, it didn't quite work. I might be able to get a thicker spring wire, or what they call piano wire. This piano wire is already 1 millimeter thick, and it didn't want to do what I wanted it to do, and it just couldn't take the shape I wanted it. So I've had to rethink a little bit this. But there might still be a trick up my sleeve where I push this through this extra tube that I'm going to have and use that as a type of guide. It might work. So still a couple of things I'll try, but I'll try that offline, and maybe hopefully by the next stream I can get that up and running. Okay, so again, just if you haven't joined the streams up to now, you'll see Hey Tyron. Hey France. Welcome. Remember, I'm going to twist it here a little bit. Remember, I've got 2 power buttons, one for the controller board and everything on this side, and pretty much the green one is for all the Raspberry Pi. So I'm going to switch both on again, and I am going to show you 1 or 2 setting changes that I've made. Once that starts up, and then I'll swing the machine around, and then we're going to do some video of some coverage of the actual bed, how I set up my bed printing space, and yeah, and then I'm also going to do the bed mesh with the beacon. You'll see that run tonight as well. And once all of that's done, maybe I'll put some plastic in it. Why not? Maybe we print something small. Just because we need to print something at some stage, so we'll probably do that. Okay, that should be up and running. Let me just double check before I switch you over. Yes. And let's go to there. So yeah, we're back in the main cell interface, and we will be looking at, the first thing that we're going to be looking at is, how I get this fan to work. This fan was part of the controller setup as part of Raspberry, as part of the RatOS configuration. So let me just go back here by enabling this over here. This fan automatically worked, right? We'll see, just for interest sakes, give me a moment. I want to see my other window. Okay. Hi Dad. Yeah, progress is getting there. Really, we're at the point where most people actually give up on their builds, because it's actually a very difficult stage, doing all the last minute configuration. It's the actual very technical part of the project, which sometimes this is overwhelming, setting up the software and doing all the changes. But if you can keep it as standard as possible, most of it is just going to work with RatOS already being there. I want to have a look. My table view is there, and let's just take this view and just pull it out a little bit. Let's have a look if we switch to this view. Okay. Oh, different views from different angles. That's fine. I think the main thing is I want to show you the fans. And let's switch that one off for a moment and switch that one on and bring you to that one. Okay, now you should be able to see everything that I'm doing. It's covering a bit of the writing, but don't worry, I'll try and keep it out of in the open what I'm busy with. So okay, that's that fan. So that fan is pre-configured, and basically what's going to happen is when one of the motors start engaging, this fan is going to come on. Just by default, that's how it's set up. It says for any one of these drivers that are moving, switch on, and then it stays on for about a minute after the whole machine has come to a standstill, and then it'll switch off again. But I want the Raspberry fan to do the same thing, because if this thing's working, then in theory the Raspberry Pi is also working. So although the Raspberry Pi hasn't been getting very hot on its own, I still want to do it. I put the fan there, so I might as well get it in. So let's start off with putting a fan in. Right, let's go. So we're going to go to a section over here down the bottom, Yeah, I've been playing with bed mesh already, so you'll see some of the stuff is there. Don't worry about that for now. Ignore that. Normally it would be user overrides. Anything you want to add, you should add it into this section, and that's why I'm going to add in this over here. So the controller fan, the fan type is called a controller fan, right? And because the controller fan will have trigger points, and typically if one of the drivers or there's some other action on the controller board, it will move. I've then given it a name called Raspberry Pi fan, right? In terms of the board, I am connecting it to, let's see if we can just do that. I'm connecting it to this connector over here. Now, this connector over here, which is fan 6, is where the current controller fan is. But because I'm not using these two fans, normally this fan would be used for the part cooling, and this is for the hot end. I'm not using those because I've got the toolboard, so I've got these two fan free. So I'm going to take this fan, and you'll see over here we've got obviously your ground and your positive voltage, and then you've got your control pin, your pin where you're actually going to trigger the fan. And then PC1 over here is what we call our tachometer pin, right? That gives us the feedback from the fan to say what speed it's turning at. And let's go back to PF8 and PC1. Let's go back to this over here. You'll see the pin to control PF8, and the tachometer is a PC1. The little symbol in front of it is a pull-up resistor. It needs a pull-up resistor to be able to work, and this is pretty much the standard settings for polling intervals on the PWM fans and the cycle times. I haven't played much with these settings. Every fan I've used so far just uses this. Some of the smaller fans, this might be a 5 as well. To work out that, I think there's a calculation or something, or you have to look at the specs. I'm not going to worry about that now because the fans are pretty much the same. You'll have to go look up that data if you need it yourself. Tyrant's asking, why is it lines blue and the other green? Okay, so Tyrant, just so for your knowledge, in this, it uses a scripting language to use as a configuration, and inside that it's almost like coding, right? So it's not but if I want to comment something out, I put a hash in front of it, right? I put a hash, or I can put a semicolon, and that comments out that line. So the greens are commented out, nothing's going to happen with them. Okay, they're not going to execute, they're not going to do anything. Whereas anything that's got colors represents something. So this is a section header, and I'm probably messing up the names here. So apologies to the guys that are into the coding side of it. And then these are more your function, or your function, or your parameters that you're going to give, and these are the variables. The variables are typically in different colors depending on what you're doing. So anything that's in green is just comments. It's good practice to put comments in as far as you need. Okay, so I've put this in now, and I'm going to save and restart. Oh goodness, you couldn't see that. I put that in there. My apologies. Right. So the fan, Raspberry Pi fan, PF8, pull-up resistor, tachometer is, tacho pin is there, and those are the two pole meters. Okay. So I'm going to save and restart. So now it's actually going to quickly reload the configuration. And we don't have any errors, so we can go back here. And if we go back to the main screen now, you'll see that it's actually included the Raspberry Pi fan. And this says currently it's not doing anything. There's no speed, and the percentage you can apply how fast you want, 50%, 100%. In the controller fan, we're typically just running at 100%, unless it's very noisy, then you can bring it down. But these are Noctua fans. These are high quality fans. So they are super silent. So I don't mind running them pretty fast. There's the controller fan that I was talking about earlier. Okay. Right, so now, oh, and you'll see the tool head cooling fan, right? Why has this one not got a RPM next to it? Because it's a 2-pin fan. It's only ground and positive. In meaning, depending on the voltage, you control the speed. You don't actually control it with pulse width modulation. So it's a 2-pin fan and not a 4-pin fan. On the little small tool, there isn't a place to put a 4-pin fan. You could probably connect it to one of the other pins. I've never thought about how to do that, but yes. All right, so first thing I'm going to do is you're going to see, maybe what I can do is, give me a second, let's just do that for a second. I'm going to pick up this fan, listen to me, camera, and put it up the top here and point it down. Have a look what it looks like on the other screen. I'll switch over. We can bring it further down if we can. Right. Okay, let's come back. Okay, so there you can see the top of the printer. And I'm going to now tell it to home all axes. So it'll home X, Y, and Z, which means that head will start moving. And because the head's moving, in other words, the motor's running. And because the motor's running, in other words, the drivers are working. The drivers are pushing the motors. Because the drivers are working, the fans are going to say, hello, we also want to work. So here we go. Right. Here soon. Both fans have come on. Right. And now I'm actively cooling down those drivers on the back end. Okay, so that's the first thing that we needed to fix, was the Raspberry Pi fan, right? Next thing we were talking about last week was the beacon probe. So by default, on the bottom of the print head now, and maybe let me just bring beacon up here. Beacon probe. Let's just open up that. And let's just switch off that, so let's leave it out of the way. And if we go to the docs, the quick installation guide, no, installation, okay, this beacon probe that's going to be sitting underneath the actual extruder, the print head, everybody's going to have a different design in terms of the cooling that they use, this cooling chamber, right? And because I have downloaded that, it's not necessarily to say that the settings that RatRig put in are the settings that I need. When I say settings, I mean the offset. So I just want to see if I can see a different picture. Okay, yeah, I can maybe show you with this picture, it's a bit easier. So if you look at this, the center of this probe is where it actually does the reading, at this very point over here, right? So you always want to know this center point relative to the nozzle, right? And you want to know in the the X coordinate, meaning is it left or right of the nozzle, and the Y coordinate, is it to the front or the back of the nozzle. Now, most of us are implementing it very much the same way. It's in 100% in line, so our X will be 0. There will be no difference between what the probe is. And if I go back to maybe this page, I can just show you on the installation guide here again. So my probe sits, let's say, roughly over here, just above the 31.6, right? So in terms of, is my probe more, the probe hole more to the left or more to the right? No, it's pretty much in the center, and that's how everybody's implementing it. It's very difficult to put it underneath the extruder and not put it there, but maybe someone's design does have it. Whereas if I was using a BL Touch or a Pinder probe, I would then have to move it across. And then the next thing is my Y coordinates, right? So how far behind my probe is it? So I've taken a measurement from this point over here to the middle of the probe, middle of the nozzle, right? And that measurement on my machine and on what I've got over here is at the moment at 17.5. So if we come back to our configuration, we could probably go through in here and go and look at the probes and look at the beacon, and you'll see that their X offset was 0 and their Y offset was 27, right? Which is not the same as mine. Now, we cannot change these files, because anything we change over here will be overwritten. In fact, if I open up the BL Touch, it would say, do not edit these files, okay? So I need to actually take, it says to you, copy that section that you want and paste it inside the user configuration. So we go back to our printer CFG, scroll down to the area where we allow to paste stuff in, which is over here. And I am going to put the following in. Alright, so let's just put it over there. Hi Julia, welcome back. Yeah, we're getting there. You're gonna see the beacon probe in action now. I hope you're gonna put a beacon in yours as well. It is just, it's phenomenal. It's phenomenal to watch. And I'll explain a little bit for those that haven't seen the difference between them. I'll show a normal probe and how long it could take. So for the beacon, I know they set it to 0, but I'm just going to make sure it's set at 0, the X offset and the Y offset at 17.5. So now at least I know where my probe is in relative to my nozzle. Okay. Now I need to set up my bed in terms of where am I going to print, right? You know, if I stick my hand up here, you've got to measure this versus that. How far can you print? Now, the 500 by 500 bed is actually 508 by 508, which gives you a 4 millimeter barrier on either side. So to take full, leverage of that, what I have to do is I first set again, I tried to use the defaults that they had in place, didn't quite work, so I have to come in and use my own settings. I think I can actually increase this font a little bit. That'll probably help you read. Yeah. Okay. So we need to tell it from where's our X stop where's our Y stop? So what we do first is we do these two zeros, right? And we do the Y's to zeros as well. Okay, I can actually, just for a matter of fact, I'm going to take that and just put it in there so that you can see it. Okay. Again, they've defined this, so I don't actually have to define 500, but it's nice when you're doing your calculations and to visualize what you're doing. So when I make these, this one's 0, that one's 0, that one's 0, and that one's 0. Okay, then you don't see my mouse, do you? I wonder if I can switch that on. Capture cursor. Okay. Oh, some other reason it's not. I can't see it. Maybe you can on that side. When I set those to 0 and I home my actual bed, let me do it. I tell you what. Let me just. I know it's -5. Let me do it quickly, and so that everybody can see. Right. I'm going to do that. In the meantime, I'm actually going to. I'm going to save and restart. Okay, and let's just go to this view. I'm going to take this camera off here, and I'm now going to restart this, spin this machine around so that we can see a little bit more than what's going on, because we don't need to really see what's happening in the back much more now. There's nothing really we're going to look at the back there. Right. We'll see how many views we can get. That makes sense. Let's get that one in there. Go and 4, please. That's what I'm worried about. Just lift those legs. You know, there's funny little stands, I must say. I don't have too much confidence in them, but they do seem to work very well. Let's have a look. If I switch that on, are we going to see what we need to see? We are to a degree. I'm going to turn this and point it further down. Okay. Let's see if we can do that. If we need to, I will zoom in on a specific area. So we've now restarted. Let's just zoom out. Oh, not out. Let's go back. Go back to our dashboard. And we're now going to home the printer quickly. Maybe I can switch cameras while that's happening. Let's switch that one off and switch that one on, and we can zoom in just that little bit that we can see there as well. Switch it up. Okay, so now it's home, so I'm going to go to position 0, position 0, 0, and position 0. Right. Okay. And I'm going to bring it down to maybe. Oh, I'll bring it down. So what you're not going to be able to see very clearly is that this head over here, right, is now too far to the front. So it's come too far to this side, and that doesn't help. You can't see me what I'm doing there. It's come too close to this side, and it's also gone too much to the left. So I'm about, based on my endstop settings that I got over here, where the actually homes, I'm about 5 millimeters too much to the left and 8 millimeters too much to the front. to be on the corner, right, of this print bed, where I'm at least 4 millimeters in from each corner of the printing surface. I hope that makes sense. Okay, therefore I'm going to come back to my settings, and this you do with a lot of measuring ruler work. Okay, you just need to measure it out. Get yourself a nice steel ruler, typically a 600 or something like that, which is easier to work with than a meter rule, and you'll quickly figure out your measurements as to where it is. Right, and so I need the stepper to move at this point 5. I need my 0 position to be 5 to the right, and we make the end stop the same, and I need it a little bit more back as well, so I'm going to go -8, which I already calculated. I need it to go back 8 millimeters and 8 millimeters, right? So now let's see this camera over here. I'm going to hold this camera up for you. I'm going to switch to that just for a second on the table. Okay, so if I hold it like that, you'll see, sort of see it's a little bit too much to the right. Okay, I'm now going to save and restart on the computer, and I am then going to issue a new homing. Okay, just move out while it's doing the homing. You can see better. Sorry for the hand, maybe I should do a little bit of a stand, but it's just easier for me to do this holding it. Alright, so now we've got the printer home. If I go to 0 and I go to 0, we come back here, you should be able to see that printer head is now moved over by like 5 millimeters, and if I had to look from the other direction from 8, it will be actually in the corner. So if I now go straight down, let's see if we can go down to 2, you should be able to see somewhere in there that thing is sitting nicely on the corner there, and that is the start of 0, 0 on my board, right? Okay, that's 0, 0, so I'm just going to hold this, and I'm getting coffee delivered. Thank you, my daughter. And that 0, 0 is important because if I now move 500 to the right, so I'm just going to show you on that screen. I'm now going to go and type 500 X, right? Move 500 across. We want it to stop on that corner, and as you can see, it's also like 4 millimeters in. Very shaky camera work, but at least you get the point. And the same will be for Y at the back. All right, so yeah, that gives you ideas to, we set the parameters of our bed now. We've got now 0, 0 at the right place, and we've got 500, 500 at the right place. The next thing we want to do is we want to make sure that we're going to do the tilting on the bed, right? And for the tilting, I can't really change that now. For the tilting, what we want to do is let the probe, let's go to this screen over here. We want this probe, there's this circle where we're going to probe within, right? We want this probe not to be over the edge of our print surface and not too close to the end. Because I'm using a magnetic bed all the way through. Remember, if you've got little magnets, you can't. If you've got the multi-magnets, you can't. But if you've got the magnet sheet, you can use the V-Core probe. Because that field, I don't want that field to be half on the magnet, half off the magnet. I can't actually probe right up to the edge as close as what I would probably with a pinder. I've tested it, it's not that bad, but I don't want to take a chance. So what I'm going to do is I'm going to make sure that when this thing sits around, that the edge of the bed is a little bit away from this, and the printer will compensate for the extra piece that it hasn't probed. It'll calculate it in the background by itself. Okay. So to do that, we need to define a couple of things. Let's get back to this. We're going to go inside here. We're going to go in the printer CFG again, and we're going to go down to the bottom here. All right, now we call this Z tilt. Okay. First thing we want to do is we want to tell it from a Z tilt positions, where are the actual pivot points, right? So I'm going to come back to my manual, hold this camera. Wish I had a little bit more length in the cable, would be nice. Let's just do a swing around and I've got a little bit more. Okay, let's go with the table view again. So if we have a look at this is actually our leg going up and down, right? So we would think this is where we need to measure, because that's the point going up and down. But because this is a straight arm and the bed lies on the magnet and it pivots on that magnet, we want to know the exact position, right? We want to know the exact position of that screw, the one on this side, and the one all the way to the back, right? As you can see at the bottom, we've got the other motor at the back, right? So we need to find those exact positions so we can tell the software where the pivot point is, so that when it calculates how much it must move, it will move relatively to those points. Okay, let's bring that up a bit. Let's zoom in a little bit so you can just see what I'm seeing. So the tilt is, again, my X and my Y roughly -5 and -5, right? Relative from the corner to the center of that screw. Okay. Then on the opposite corner, on this corner on this side, it is 505 and still -5 because it's still on the front, and on the back it's in the middle of the bed and it's beyond the bed with about 4 millimeters to the back, right? So those will give me my 3 screws that this whole bed's going to pivot on. The next thing is I want to set where I want to take measurements from, right? So that it can calculate whether the bed is level. Here's where it comes in, where I could ideally say, you know what, I want you to measure on 0, right? But if I measure on 0, I run into this issue that half of this magnetic field over here might be over half of the magnet, and I don't want to do that. So I want to move in. How much do I have to move in? I typically have to move in about 11.5 millimeters, right? But I have been playing a little bit, and while I'm doing settings, I will take a little bit more safety. I'm going to sort of almost double, instead of 15, I'm going to like double that distance of that circle. Later on, when I know everything's working well, I will reduce it a little bit and see what the difference is. So I'm saying go in 30 to the right, and then I'm just moving it in by like 10 because the probe is very close to the edge. I'm just bringing a little bit more back, pushing a little bit more back onto the board, again, on the other side, I'm not going all the way across. I'm going 30 short of the full length of the bed, and I'm going that 10 backwards again. And in the back area, I'm saying, okay, in the middle of the build plate, but don't go all the way to 500. Just really come in for me to about, I could probably do it at about 470. Let's do 470 because it's about 30 is fine as well. So there we have our probing point. So it's going to probe at this point, then it's going to probe at that point, then it's going to probe at that point. It's going to take those measurements and calculate based on the fact that the screws are in different locations, how much it needs to twist the bed. Right, so let's save and restart here. And we go zoom out again. And in this case, we can now just maybe do that. And let's turn this camera slightly. Let's see if I just change this light, if I get a bit more light on that thing. Doesn't make too much of a difference. Okay. Anyways. So before I now actually do the homing, and while the motors are off, right, I am going to, on purpose again, tilt the bed down on the right corner a little bit, which you can see this right corner is now slightly lower again, and I'll tilt the back a little bit as well. Okay, so this whole bed is actually now standing at an angle. Okay, I'm going to do my homing. Right, that's X and Y homed. Yeah, Z home. I picked up Z. Right, and now I'm going to push my tilt button, right, which is now going to go do those 3 measurements to try and figure out how to adjust the bed. So first thing is going to come to front left, and go to the rear. Now front right, and you must now watch this because this corner is going to go up. Okay, actually it did the opposite this time. Made that corner go down. I didn't realize it was going to do that. I think it just moved that corner relative. So you can see that bed is a lot more level now. And on the side over here, you can see it's now probing again. The range, the tolerance that it's looking for. The previous tolerance was the range was about 8 millimeters, 8.7 millimeters difference. Now the range is 0. something millimeter. Then it did a 0.3 millimeter difference. And now it's 0.006 difference between the 3 corners, and therefore it now considers this bed level. I'm going to do one more homing. Yeah. While it's busy with that, so now we've got the Z tilt ready, bed level, but now we want to do the mesh. All right, we want to probe the bed 7 times, 7 columns by 7 rows, so that we can build a virtual understanding of how the bed actually looks. Now, I'm not very happy with the virtual at the moment, but I'm going to show it to you in any case. I'm still trying to improve it. I don't know if it's the bed that's actually warped or if it's part of me building the machine in a specific way. Once I know that, hopefully I'll be able to in the next stream just tell you what I did to make a difference. Going to the bed mesh, right. So we're going to now set up the bed mesh. The bed mesh needs to have some parameters. So let's go to machine, we go to RatOS, we go to probe, beacon. No, it's not in there. Where is the mesh settings? I can't remember where it was. Maybe if I go to printers V-Core3 and we go to V-Core3. Sorry guys, I can't remember where the mesh settings were. V-Core3.22 unknown steppers, macros, input 500. Here it is. Okay. Alright, so in their configuration file again, remember, do not edit this, right? They don't want us to edit it. They've set up the bed meshing already for you. Okay. Now I could just leave it like this, or I can decide I want to override the parameters. Okay. Because I wanted to play it safe and I wanted to keep that 30 away, I can't really use theirs because theirs is like a 20 away and at the back slightly different. So I want to copy, I just would normally copy this, and then I'm also going to copy the number of probe counts. They're doing a 7x7 grid, right? I want to do a higher grid count, so I'm going to copy that section and I'm going to come back to the main printer where I'm allowed to make changes. Okay, so how does the machine the software not know to use that where I was now? How does it know to use the settings which I copy into user? I don't think I've mentioned this before. So the software executes logically through this list, right? And as it's executing logically through the list, that setting will be included there. There it gets loaded, right? Then it carries on, and as it's going along, comes along to the user setting, and then I give it exactly the same parameter call, right? And I say bed mesh again, and I set that variable again. So I'm effectively overwriting what was already there with the new settings. So I don't need the horizontal. I'm not going to worry about changing the horizontal move. That's still in the main config. Oh my god, sorry. Let me just undo that so you can see what I was. I don't need the horizontal move. That is in the main config. I don't want to overwrite at this point, so I don't need to include that. Okay. The min, I want to say, listen guys, I want you to read rather from 30-30, so x30, y30, meaning slightly in the corner, or in this case 30 and 10, because that's my probe points that I used at the top there as well. I'm going to use exactly the same. And the maximum I want you to go to is the 470, right, by 470, okay, which is my maximum x and y position. What it's now going to do is now going to calculate and split x up equally and y equally, right, into a 7x7 grid, and it's going to go read that. Now, if I take Let me just stand up quickly and grab something in the box here. Here we go. So this was the Pinder probe that was originally on it, right? It's it's the inductive probe. Okay, and this inductive probe, I'll see if you can see it better. Yeah, I can't really. This probe has to go down to read and up and down and down, and it's got to do this basically. You can't fly it as far as I understand, right? It takes longer to read, and it takes longer to get the data to the Raspberry Pi to compute. The beacon doesn't do that. The beacon just flies across and it takes the settings as it needs, right? And it reads the bed height on the fly. So I'm going to do even a higher count because it makes no difference to me in terms of speed. I'm going to do a 15 by 15 grid, which is meaning I'm going to now do 15 lines backwards and forth, and I'm going to take 15 readings along that line. If I do this on my other machine, it takes me up to, if I do a 15 by 15, it could take me up to about, I don't want to lie to you, probably a good 8-9 minutes to do the probe, right? That's how long it will take me to finish it with this. You'll see how long it takes with this one. So now I'm going to save. It now knows what probe mesh I want to have. Okay, come back to the dashboard, and you can see there's nothing loaded at this point, although I did some demos earlier today just to try and figure out the bed itself. Again, I have to home before I can probe. Every time I restart, I've got to rehome. Every time I print, I'm going to rehome. Rehoming is something you do one heck of a lot, right? But this machine doesn't take long to home, which is quite nice. All right, so there we are. Now we're going to go to the heat map, and we're going to say calibrate, and let's just call this stream. Right, we'll just do a stream mesh. You can keep it as default if you want. I'm just going to give it a specific name because you can actually save multiple meshes, because normally when you do a mesh you do it with the bed at a specific temperature. All right, because whatever you're going to print it, as the bed heats it will twist in shape. So you want to get the bed up to temperature. Once the bed's up to temperature, then you actually want to do a mesh. Now on the old machines it takes too long to do a mesh, so what we do is we create the temperature, we get the bed to the temperature, we do a mesh, we save that, and every time we print at that temperature we just recall that mesh. But with the printer with the beacon, here we go, I don't have to do that, because there it goes. It's now going to do it's going to take 225 measurements in one direction. Then it's going to turn around and do another 225 measurements on the way back. This beacon probe is really phenomenal. Right, it's on the last row. It's coming back. Now it's going to do it again. So taking basically 2 measurements of each point. Done. $450 measurements done. That was fast. It's really phenomenal. It's a game changer in terms of doing bed leveling. And with that, we now have some info, right? Stuck behind this picture, sorry, not this one. Stuck behind there, you'll see there's the mesh name, right? Can bring that back in the corner. It was a 15 by 15 grid. Its highest point was 0.188 of a millimeter, and its lowest point was 0.3 of a millimeter, and it gives you the relative coordinates as to where it found those, right? Now, yeah, it tells you the range, so that means between the highest point it received and the lowest point, it's picking up a 0.5 of a millimeter difference. Now, in essence, it's not going to bug me when I'm printing, but I'm noticing that there's something strange, because if I twist this around, this corner means that there could be a possible problem with my frame alignment. And now I need to go and do some researches, because I've never done this before on a Core XY. My first Core XY where I'm actually running this probe system. And it also would seem, if you look at this, that in the front of the bed, it's rising up for some other reason. This could be the bed, and it could be the frame. Before I actually go to anybody and say, hey, it's the bed, I need to double check my frame. So I'm watching a couple of videos, and hopefully I'll be able to post an update at some stage saying I found the problem. But still, I could print on this easily, without any doubt. There's no worries about printing on that, because it's really not that big. Okay. What I would now need to do is, either if I'm going to reuse this mesh every time, I can hit save config, right? And then I can recall this mesh name every single time, the stream mesh. Every single time I want to use it, I just recall it. I don't have to do a bed probe. But because it's probing so fast, before I do a print, I'll just let it do a probe every single time. But I'll save just for showing you what it does. Oh, Julia, I bought this probe. It hasn't seen one piece of connector on it yet. Hasn't done one probe yet. And I bought this beacon. I thought, you know what? I'm almost prepared to throw this away and put that beacon probe on every single one of my machines. Just simply because it's so easy to probe now. But again, it makes sense on the 500 by 500 definitely to do that probing. Maybe what I'll do is put this on one of my older printers. I've got a lot of BL touches. I like the BL touch. This was my first Pinder probe. I was happy to go with the Pinder probe just to see what it would do. Because it's a little bit faster than the BL touch, at least. The BL touch you can't go too fast. But yeah, if you can afford to, while you're busy, and you got the capacity to put that the beacon in, just go and do it and get it over and done with. Alright, so now you can see there's two different meshes that were saved, and you can see there's something not making sense because things are moving, right? And I need to figure out why. And I think it's got something to do with, first of all, this Discord demo was done at 100 degrees Celsius, 110 degrees Celsius, so I will probably have to do a complete cold scan and a hot scan. If the corner at the back stays the same, then it's most likely frame related. If the whole bed changes shape because of the heat, then it's most likely more bed related. Theory, but I'm pretty sure that's the best way to look at it for now. Okay, so we're ready to print something. Now, I could show you that I'm busy with the heated chamber. What I will do for you is show you the following, but I'm not going to actually connect it up and get it running at this point in time. So let's just switch over to this view. So over here, I've got two PTC heaters standing at like roughly 45 degrees that I've made a housing for, and they will be blowing air up inside my printer from both sides and heating it up. Those two are controlled with the SSR that I specifically put on, and I will have a thermostat probe somewhere at the top of the printer, so that I can measure the temperature at the top of the printer and not at the bottom, right? Because it needs to be, it really needs to be at the bottom, at the top of the printer, what the heat is. Because I'm aiming for a 60-degree chamber heat. So typically I want to measure temperature at this height, right? Roughly at that height. As that height is finished, as it starts printing and as the chamber starts heating up, the hot air will actually rise up, hit the top, and then it will start pushing down, and slowly but surely the whole chamber will become the same temperature. Now, I did think of putting a thermostat at the bottom, but that would just be for informational purposes and wouldn't really make any difference. Yes, Mr. France is asking a good question. Any blue sparks, lights coming out of them? So France was, yeah, when I tested the initial inaugural power on of those two boxes, of those two PTC heaters, and he was watching it nicely, and I said, okay, just have a look, and then when it's up, you're going to feel if the hot air is coming out. And I switched them on, and they ran, what, 10 seconds? And the next minute there was a loud bang. And I saw France jumping backwards a little bit nervous. He said there was just a little blue spark that came out of that, the right hand PTC heater. And well, as luck would have it, I just had a dud PTC heater. Nothing I can do. You know, it's pointless sending it back to China. I just threw it in the trash. I had another one on my other printer, ripped it off, plugged it in there, and ran it the other day for 10 minutes. No issues. Yeah, it wasn't that shocking. You didn't get your finger in it. So I missed, as I say, I missed the blue spark in the pixie smoke coming out. It would have been nice to have had that on camera, but I missed that opportunity. Didn't know that was going to happen there. Out of all the places, I would have never expected it to go out there. Any case, those are the two PTC heaters, and by the next stream you will see them in action, because I will have that also ready configured, and then we'll be able to also close the printer up and start building the heat up inside. Okay, so let's go back to, yeah, and we're going to let's do this. We're going to load some filament. Now this is going to either go horribly wrong or it's going to go right when we do this first print, but I'm willing to take the chance on the live stream, so let's do this. So I'm just going to first home this printer. And I'm going to grab a roll of filament. I'm just trying to think. I've got a 0.6 nozzle in there. I've never printed with the 0.6 nozzle. My idea is to stay away from the 0.4 on such a big machine. Go to the 0.6 rather. So we're going to keep it there. I think I'm going to take the chance that the first print might not be that great. I'm using just a eSun PLA Plus here. It's a filament that I use a lot. I know the filament well enough. I trust eSun's PLA Plus for relatively consistent prints. So let's do that. I still don't have the new liners, as I said. Those should be coming soon. So we're going to have to make the filament go in a different way. Okay. Which is fine. I think what I can do is I can just take one of my rollers. Let's grab one of these filament holders, or filament dryers at least, and I'm going to chuck in a piece of filament over there. In the meantime, we're going to let the temperature build up a little bit so that we can actually get filament to go through. Now, this is not the best way to route your filament, but in the name of doing something today, we're going to try it that way. I had a blue tube somewhere. Maybe it's up here. Inside here? No, it's not. Ah, there's the blue one. We're just going to sort of guide it at the last little piece inside. Let's go a bit closer there. Well, we actually need to go quite a bit closer. All right. We have hit temperature, so I'm now going to pull, let me just move this picture a little bit that way so that you can see. I'm going to move 100 millimeter at 5 millimeters per second, and I'm going to retract because I want to pull what is in there out. Let's just pull that out like that. Right, piece of temporary filament that I had inside there, because earlier today the filament sensor that's at the top there, oh, and I haven't connected the filament sensor yet. I need to do that as well. That I have to figure out, because I'm not sure how I'm going to connect that filament sensor. Although I don't need it now, I'm not sure how I'm going to connect that filament sensor up in the long run. Let's cut this filament off and just feed take it over the top here. Let's move that camera just a little bit that way. Let's see a bit better what I'm doing. I'm just going to push that into there for now. This is all a temporary solution, guys, so don't think this is how it's going to be in the future. Okay, and I am going to then make it extrude. Okay, it's got it, and we're going to see some black plastic push out the bottom there. A little bit shy on light in the front here. I wonder if I can get this light down without blinding anybody over here. Just let's increase the space. Right, let's just push some more through. Just slow it down slightly. Yeah, just pushing some plastic out. This camera is very dark, and I don't know why it's not. There you can see a bit better now. So to get it to change its lighting a little bit. Okay. So now, I think you remember I said on their website they showed we should use the super slicer or configurations. I had to look a little bit further as well, and I want to just quickly go to bookmarks and go to that wasn't Turbo, sorry. I wanted to go somewhere else on a different page. Bookmarks, let's go into here. If we go to their website, we can just use that for now. We'll go to the firmware page over here. And here's the slicer configuration. So they actually give slicer configuration information for both Cura, Prusa Slicer, Super Slicer, and that's the one we sort of downloaded and installed the other day, and also for the Orca Slicer. Now I'm an Orca Slicer fan, so I'm going to stick to the Orca Slicer. That's where I want to be. What I'm going to quickly do is just, without you having to look at everything I'm doing, I'm going to go to my apps, installed apps, and I'm going to have a look. Did I, by accident, well, not by accident obviously, did I install Orca Slicer? I did. Okay, I'm going to uninstall Orca. Yes, uninstall Orca, please. And then we can quickly run through the basic setup of Orca Slicer. Again, if you're comfortable with Prusa Slicer, use Prusa Slicer. If you're comfortable with Super Slicer, use it. If you want to use Cura, it's there. I don't know who still uses Simplify 3D, but yes, there are people out there that still use it. So use whatever you're comfortable with. I know that for a long time RatRig have supported Prusa Slicer and Super Slicer, and that's why pretty much that's what they recommend, but they do support other slices as well. Right, so I want to have Orca Slicer, and as I said, Orca Slicer was so Super Slicer came from Orca Slicer, right, and Orca came from, Super Slicer came from Prusa Slicer, and Orca Slicer has been a combination of a whole lot of stuff that Bamboo have done, Bamboo Slicer, and a couple of other things. So it's really at the moment the slicer that's getting the most attention because it is getting the most releases as well. So 3 days ago they had a release, Orca Slicer 1.8, release Candid 2. I'm not worried about whether it's got bugs or not, so I'm just going to use the latest release candidate. But if you feel you don't want to use the latest release candidate, you can go to the releases and you can just go back and say that's a release candidate, and there's a beta 2 release, beta release. I'm going to just go back and they show you all the stuff that they fixed as you go through it. Let's just go a little bit further back. There's 1.7 was the last official release. Okay, so that's the official release, and then they start with the next version with betas. So just to give you an idea, this was on the 14th of September, right? If you now go to their beta, their first beta was 3 weeks ago, then 2 weeks ago was beta 2, then the first release candidate, which they're trying to get finalized, is 4 days ago, and their release candidate 2, where they fixed a couple of minor stuff, was 3 days ago. And I tell you, probably in the next week or so we'll have maybe even the official release. So I'm not too worried about that. Whatever's still buggy inside this one is minor, and you can just reinstall as and when needed. I'm going to use the Windows installation. You get a portable version as well that you can use. You can run it on your Mac, and you can run it on Linux as well. Hey Julia, yeah, I'll put my printables link there, but I haven't posted anything of my changes yet. But in the next, let's say in the next week, I'll start uploading some of the stuff that I've used. At least the STL files, if not the step files. I'll also upload over there so that you guys can get hold of some of the changes that I've done. And then you can also see any of the collections that I use and where I got some of my actual prints from, because pretty much every other person's print that I've used, I put it into a collectible so that I can find it again. Alright, so let's go and install this Orca. Have you started building your machine, Julia? Run anyway. Because if you haven't built your machine, there's a video I recommend you watch before you actually build it. It's about getting your it's about getting the frame straight, and they actually recommended, the guy recommends building your RatRig slightly different, so it might be worth having a look at it. I will probably drop that in the comments section after the stream so that you can just go and have a look at that video as well. Alright, so let me bring the installation to the screen that you can see. Here we go, next, Agree. Next. Next. Not much exciting over there. Pretty much standard installation. Finish. Now it's probably going to start up on one of the other screens. Or not. Let's just give it a moment. I don't know if it's actually starting up. Let's click on it. Where is it going to open? Which of the screens will it open on? Right. Can't grab it yet. Sorry, it's opening up another screen, but it's just a flash screen saying based on Prusa and Bamboo Studio. Right. Now normally it would pop up with a configuration. Let me see if I can run through the wizard. See, and the reason is because I've already installed. I installed it previously, so now it hasn't totally removed it. When you uninstall it, doesn't always remove all the previous configurations. How do I rerun? No way to rerun it. Ah, there it is. So the setup was it. That's what I want to run. Okay, so normally it would pop up with this as the first option, and you would then choose your country. So believe it or not, UAE is in Asia, so we'll just Asia, and then as you can see, you can use multiple different printers. You can use a generic clipper, generic Marlin. But then they start listing all the printers, Anycubic, Artillery, Bumblelab, which is this Bumblelab. This software is actually based on part of the Bumblelab slicer, and BQ, Congro, Creality. That's my other machine. I've got a Creality is one of my other machines. I don't know if I don't see it there. Although my machine is no longer Creality because I run Crip on it. Nep Elegoo, Force Slash, FL Sound, Forge Tech, Ocarina. There's your Prusa slicer, which most people know. QD is very powerful brand. Oh, these guys are powerful. This is an amazing company, this Raise 3D. They've actually got a big branch in the UAE, but they work with, this is more commercial grade printers. And eventually we'll get to RatRig, and you'll see RatRig V-Core3, 200, 300, 400, and there's the 500. Ticked because I previously installed it. Okay, and then you can install your other printers if you want. What I'm going to do is just keep going down this list, because I plan to do a Voron stream for you guys at some stage, and while I'm about it, I'm going to install, there's the Voron, right? So there's the little Voron next to me, one of the most reliable little printers I have. I'm going to install the Voron 0.1 as well. Okay. And then you can just go through all the others. Next, what they do is they try and associate the different filament types with the different printers. I'm just going to put it all there for now. although, you know, I won't probably be printing all of these. You know, PVA definitely not, and ABS, and I started printing TPU the other day for the first time. But anyways, I'm going to also on the Voron do ABS, ASA. You know what? This is a carbon fiber. PETGs, PLAs, PLA with carbon fiber, PVA interior. Let's just put them all there. Right. Doesn't really make that much of a difference. Okay, so then your slicer is ready to go. You go to your prepare settings, and I'm definitely not going to be printing on the Voron today, so I'm going to switch that over to the RatRig V-Core. Right, that's how it will come up. I then went in here, and I can. Why? There's something wrong with my font size on the screen. Why am I getting such a horrible font size? Okay, not sure why I'm getting the font size so difficult. Printable space. Okay, so again, the printable height, you're gonna set up the printable height, your traction, extrusion, your extruder, and some default settings that are there. Pretty much, you're not going to change too much on that one. I'm going to switch on advanced. Always switch on advanced. There's a lot more information there. So if I go to basic information, I can print a 500 by 500, right? Oh, yes, and 0 is in the corner. 0, 0. Just for your interest, that's the way I set up. Some people put 0, 0 in the middle. Yeah, good evening to the wives from upstairs. Relative distances, we want to switch that on. And where is my extruder? Yeah, so because I'm not going to be printing with a 0.4 nozzle, I changed this to a 0.6 nozzle, right? And then when I change it, let's just do that, and I hit save, it's then going to not want me to overwrite this original setting, and it's going to want me to give it a new name, right? And so typically I would then say 0.6, and I'd give it a unique name, because maybe I'm going to have different settings for different for the same printer. I might have multiple different settings. You can see I've already got that, it already exists, so it won't let me save. Hence, if I close this, I can select the 06, which is under the user presets. Alright, so inside that you'll see that my extruder is already, oh, I didn't set it at 0.6, it didn't save. Okay, so let's just save it there. Nozzle diameter 0.6, save. Right. I'm going to leave everything default. We're going to really chance it and see if we can get a printout without changing too much. I'm going to use a generic PLA. Oh, before I do that, let's go and connect the printer. So you've been noticing that when I'm working on the printer, I go to this interface to control the printer the whole time. Okay, let's just let that thing cool off. Don't need it running all the time. And Super Slicer, you've got to switch between your web interface and the slicer. What Orca have done, which is nice, is inside here, once you connect to your printer and you do a test, you know what your IP is, it says connected, and you say OK, you can click on device, and it actually brings that whole dashboard inside your slicer. This is really game changing. It makes life so much easier. Otherwise, you're switching between applications the whole time, and it really becomes messy. Specifically, if I'm printing to 3 printers, then I open up a second slicer. But in order to open a second slicer, I've got to open up a second browser tab, right? This makes it so much easier that I can just work inside here. So just go in there, get your IP address, set it in, do the test, it'll connect automatically. Then for PLA, it's got its standard settings here, and I'm just going to have a look at what temperature. It says it wants to print at 205. This I know prints well. This PLA Plus prints well at about 215, and let's print 215 all the way through. Right, and we can keep the bed at 60. Oh, we need to get a first layer calibration done. So we might need to first do one little print before we can do a block. In any case, we'll do that. I'm going to keep that all standard. I'm not going to mess around with that any further. Let's just call this RatRig stream. Okay. We're going to leave everything as standard, just the temperature change, and we're going to use the standard 0.20 layer heights, and we're going to leave the speed the same. We're just going to let rip on this one. So I am going to need to do a first layer print. Now, you can use this calibration, and we can do a temperature tower, and we can do flow rates, and we can do pressure advance and retractions and all those things, but I really want to get my first layer calibration correct. I'll just have a look. There's a calibration there. Right. So what I'm going to do is I'm going to quickly grab on my printing. I've got a 100 by 100 0.2 first layer test, which I like to use. Right, let's pull that in. Okay, doesn't like the geometry, center, and that is pretty much one layer. Genuinely, it is one layer thick. Okay, so that just helps me get my initial printing down to the right level, the head, and I'm gonna slice, and I'm gonna hit print. Yeah, there we go. Let's hope it works. So you probably want to see what is going on, so let's do that one. Just coming back now, if we go back here, we can go to the device. We can see it's getting ready to print, right? And its bed heater is busy heating up to 60 degrees. Oh, you know what I didn't do, and I must apologize. Let's stop this. Very bad mistake. Let's just stop that. Let's come back here. If you look, we go back to the website, we go back to this over here. It says to us that we should, in our G-code our starting G-code, we should put this in. So we're going to copy that string, and we're going to go to our slicer. Now, you could put this G-code in a couple of places. in there, all there. I'm going to put it in. Let me just have a look. I'm not going to put it, you can't see, start print is there. Okay, don't worry about the printer, it's going to do a couple of things, but it won't start basically printing as far as I remember. I'm going to paste that line there. Let me see. Alright, they've already put it in, so I actually didn't have an issue. I could have left it. How nice of them to have put it in already. Okay. Oh, it hasn't stopped the print. So it's actually now doing, it's doing the bed leveling. Now it's doing a Z height level again. Now it's going to do the actual probing for the mesh. So it started off with homing, then it did the Z tilt, right, made it level, then it did the home. Now it's doing the probing to get the mesh. When it's finished with that, it should create a print blob. I want to see if I move one of these other cameras a little bit further this way. Can I get this camera up here? Let's move this. Let's see if that works. Alright. It's a little bit far away. It doesn't make a difference. No point in putting that one in there. Okay, not to worry. You'll just have to excuse while it's a little bit off screen. This one we can maybe just tilt up slightly. Oh, I see what's happening. There's a problem with the light at the back there. Okay, so what is the printer doing now? We come back to this screen. You'll see now it's increasing the extruder temperature to get up, and now it's going to do a blob on the corner, which you're not going to be able to see. A priming, what we call a priming blob. Let's see if I can move to this one. You see in the corner over here, it's now going to do a priming blob, a little bit far away. Let me grab it closer. Let's see if we can bring that into, right, a little prime blob that it's making. Although it's a very funny looking prime blob. You ever seen that before? I'm not sure what it's going to do now. Let's have a look. It is done. Well, that was very unsuccessful. Oh, it was cancelled. Oh. Okay. Because I cancelled it, it did eventually cancel, so I'm just going to let it run again. Sorry. Here we go again. That was such an anticlimax. We'll have to try that again. But I'll hold this camera in place now so that you can see it a little bit better. I need to get rid of this little blobs that we did over here. So let's first the homing. finished the homing. Now it's waiting for the bed temperature to increase, because before it can do the bed leveling, the temperature has to be correct, right? And it's also heating up the extruder of the nozzle. Okay, so now it's going to do our bed level. Move my chair a little bit so I can stand nicely. Watching work. I have not started. Everything is making my rear electronic panel before I start. Yeah, the DIN rail definitely makes a difference. So I agree, Julia. If you're going to do it, do the effort to put the DIN rails in. It's a lot of effort. I don't know if you've got another printer. With another printer, at least you can print a lot of those clips up front. If you don't have it, then the DIN rail is a bit of a challenge. I'm lucky I've got two other printers I can leverage off to get that done. In actual fact, all these parts I printed myself before the stream. I actually ordered them initially, and the parts that arrived, the quality was just not good at all. So we're doing the bed mesh quickly. I would have loved to have been able to cut my own panels as well. Would have been very satisfying. I see RatRig have now also brought out their own tool head, which is slightly different to the EVA, and it's only built for the repeater. Yeah, I might consider doing that, but I also, because I'm going to do a tool changer, it might be a waste of doing that as well at some stage. Okay, so it's now heating up the bed again. Now I'm going to come across. It's going to now do the prime blob. Funny method. I don't know if I can get the camera to focus very well there. You can probably just see the bottom of there, creating a blob. It's pretty much just cleaning out the nozzle. On my other print jobs, I do a print line. Now it's getting that piece that overruns out of the way. And here we go. So it's the first line. I can see it might not be too bad, the layer height. Here's the first bit of plastic really going down. Let's bring it down here. So I do this so that on my screen, and I'll show you now, you've got, I'm just going to turn the camera to it. You can do minor adjustments to the Z offset. So if your lines are too far apart or too high, you can lower it or make it higher. and you can adjust it until you've got that Z offset correct. But I'm having a look over here, and I might just have nailed it almost perfectly on the first try. And switch to the camera for a moment. I'm going to bring my flashlight in just a little bit closer so that I can see what it's doing. My goodness, I'll be shocked. That is probably like the closest I've ever got my first layer done on the very first try. Tyrone, man, I've got some housings I need to print. Let me show you. I'll see if I can pull it out here while that's printing. Where's that other housing of mine? Let me go have a look. So it's while that's printing, we can put the side camera on as well. So Tyrone, this is for our camping, I have a solar panel and a battery and everything that I carry with. And I built an instrument panel, designed it, and I couldn't print this as one piece because my printers weren't big enough. And I actually had to cut off, make this too tight for my other printer, right? I couldn't get it through. And because it didn't have a proper heater chamber, it also started warping. So this is next week. I have to print this thing and get it over and done with. This printer is going to work next week. I need to get the panels on. I need to get the heat in the chamber correct so that I can get this printed. And I actually want to print it as one piece. This sits over the lithium ion battery and clips on, and on the back over here I've got the solar charge converter and the 220 volt inverter, so that I've got power. I can power fridges and things like that when we go camping. We're going camping in about 2 weeks again on an island, and so we need our power. Yeah, so this is, you can see there's quite a bit of print work inside doing that, but it's definitely, this printer's going to print big things. I'm planning on printing a dolphin skull in the next week or so as well. I've ordered bone colored bone colored PLA, so that we can print bone like skulls for the one client that I'm working with. Okay, we're almost there. This is shockingly good. This is when it all pays off. You feel really satisfied, specifically if you hit your first layer like this. And there's no tuning done yet. I haven't done any pressure advanced tuning. I haven't done any flow control, nothing. This is just straight off. Right, so that's your first layer. Normally I would need to let it cool down a little bit, but I'm going to stick my nail underneath it and see if I pull it off. There we go. Okay, so how do I prove to you that it actually looks pretty good? There's a little bit of flow issues here and there, but in general that's great. So let me go to this camera and I'm going to turn that down. And we can go to this one. So there's the first layer. You can see there's a little bit of artifacts there, but I mean, that's zero tuning. I've done nothing whatsoever. That's the bottom layer. That's just amazing. And I can tell you, I don't even know if I'm going to change my first layer height because it is just perfect. Wow. Okay. So I can stare at that for a little while. Let's come here. Let's print something a little bit that will show the machine's current status. We're going to say new project. We're not going to save. That'll just discard because it was there. Gives me a clean power. Right, I'm going to go here and have they taken? They've taken away the cube. Flow vertical fat on temperature. Oh, where's the? This is part of the calibration. Orca's got a very nice calibration, how to do your pressure advance and all these things. I obviously will do this as I go along, and I'll try the different temperature towers and how to control that. Vertical artifacts, your tolerance testing. This is quite your advanced calibration, your flow dynamic, maximum flow printing speeds. Really nice. Okay, doesn't look like they still have the cube inside it, so unless they've hidden it somewhere, which I thought there was a sample print. Oh, okay. Let's see, do I have a cube in my list? 3D printing, maybe under what have I got? General calibration. XY. I'm not sure which one is which one. Let's open both. Yeah, a bit of a boring print that. Do I have anything else that's interesting? Unfortunately, this toaster and the clearance castle takes quite some time to print. Where are we now in terms of, we're really on 2 hours, so it's going to be a very boring cube, sorry. Or let's see if we can get at least a RatRig. Let's see if we can get a RatRig calibration cube. Tinkercad printables. RatCube. Let's download this one quickly. Yeah, let's at least print something that's relevant to the Mark III. pre-chamfered. How does that one look? Let's have a look. Yeah, that looks like something we should print. Just because we can. Right. The str3mf file. Let's download that one. Right. Delete that stupid little cube there. Although it's still going to be a small little cube, we will print that cube. Okay, no problem. Right. And because we don't have much time, I'm just going to leave it the same size, and we can then see that's what the cube looks like. Let's slice it and say print. It's got a 34-minute print. If you guys don't mind, we're going to start that one. Okay. All right, so let's run that. Let that print run. What I can do while that print is running and gets going, I will just quickly talk to you about belt tensioning. So that's one of the things I've been battling with today, is actually getting the belt tensioning right. For some other reason, I'm just really battling with it, but I'm getting closer and closer. This print looks really good. Yeah, really looks good if you think about how many other prints you do, and you've seen what the first prints look like. If we go to the slicer, or let's go to this screen. There we are. Let me go back to the main browser. It's busy with that in the background. We'll have a look as soon as it gets going. So one of the things that it allows, oh my goodness, it doesn't allow now because we're busy in a program. There is a macro called belt tension measuring or something like that. And basically what it does is it uses the resonance measuring device inside the toolboard, and it can actually determine by using vibrations which belt is tighter than which belt. It can try and get the belts tighter. So when it's finished, it drops a file into what we call input shaper, and you can see I've done quite a few today. But what I'll do is I'll open up, let's open up this one. Brings up this graph, okay, and it's basically saying there's the upper belt and the lower belt, right? At this point, it seems like the upper belt is much tighter than the lower belt, right? Because these peaks need to be closer to each other. So what we need to do is tighten the belt. Now the process takes a little bit of time. You've got to go through multiple iterations, and the vibration probably takes a good 5 minutes between each process, to actually run the resonance test. And I'll just leave that on that side so you can see what's happening over there in the meantime as well. Over here you can see this test. Now what I'm going to do is I'm going to open this image in a new tab. Do that. Right. So you can see it over there, and I'm going to shrink that down just slightly. Okay. Come back here, and I'm going to then open up the next one that I did. And we can now actually sort of like compare these two. Let's line them up, give or take the same. While it looks like the peak hasn't changed, you'll see that from this peak, which was done before this one, actually, sorry, the other way around. Yeah, this one was done before. This was over the 6, and now we're halfway between 5 and 6. And this was just below the 3 point, let's say 3.4, and now it's slightly increased. So the gap over there is actually changed because we're having a look at that section, right? If we now close this one and open this image in a new tab, right, which is, let's just shrink it again so we can see. Okay, so we've got that one. We then go to the last synchronization, and every time all I've been doing is tightening the bottom belt, just a slight bit, just a little bit of tighten, then come back and test, a little bit more and test, a little bit more and test. And so you'll be able to see over here that this peak of the blue one is now dropped under 2.5, where it was over there, and this was over 5. The yellow one, which is the top belt, was over 5, and that's now dropped to just over 3.5. So these two gaps are getting closer slowly as I'm tightening the belt, but it's a lengthy process. So I've got to just take my time in doing it, because if you tighten it too far, which I did today, and I was a bit hasty, it then jumps totally over to a new scale, because it's like a guitar tuning, right? If you tighten a guitar string too much, it actually jumps into like a different scaling automatically, and really goes horribly wrong fast. You know, you mustn't over tighten quickly. You must do it slowly, so that you can get to the right tension. And the same on these belts. You've really got to go slowly on that. I actually broke the one clip today because I tightened it too far, and I didn't realize what I was doing. I didn't realize it actually tightened it that far already, because I was just impatient. Okay, so now this printer's going quicker, and my whole table is shaking. Right. So let's see if I can bring you up to speed with this camera a little bit. Let's go with just this one. Make sure you can see the speed of this. I can't get closer for you, unfortunately. I think my other camera is going to fall off the top there. Now difficult to see in the bottom there. And this printer's moving. I don't print this speed on any other printer. I'm not capable of printing this speed on other printers. The camera is going to make you sick if I hold it like that. Okay, so let's keep going in the background there, and look who's come to visit. Our local little mascot, which today you can have a moment, okay? Because I'm not busy the whole time. I'm waiting for the print. I'm trying to think. Oh, you know, the other things that I still need to do on this printer. So as I said, I'm going to put lights in. Let me show you what I'm going to do in terms of lights. I'm going to just quickly switch to this view. You can watch there for a second. So, okay. So these are the lights that I'm going to put in. They're just normal LEDs. They're not RGBs. I'm not a pink, blue, green person. I just want normal lights. Right, and I've got 4 of these. And these 4 will be going into the top part of the printer, showing down, like showing down at an angle. So they'll be just a little, you can't see it now, where on the top of the screen, but they'll be showing down like that, and there'll be 2 on either side to give me light for when I'm doing video footage of a print. I need to get that in place. Those lights, I can show you actually what it looks like when they're installed on my Voron. So let's have a look over there. Show you quickly there. So very bright, but I've got lights on either side of the Voron, which give you nice light on the bed. Unfortunately, you can see that camera doesn't like the lights like that, but I think if you open up and I get a different frequency camera, I might be able to compensate that. I need to figure out why I get such bad resonance on that camera. I might need to use a different camera, but those lights are pretty much just pointing downwards. If I open up the top, that's what it looks like, little housings. And I'm going to do the same in the other printer as well. Now these lights I can control the dim, how bright I want them. This is only 30%. You know, it is really not that bright. So let me go to this Voron printer quickly. If I switch this down to 10%, you can see it's still, it's very not that bright. 100% is probably, you're not going to see it because the camera is going to compensate for it. Although at 100%, you can see that the lines have disappeared. Somehow it's figured it out. The frequency has disappeared. It's now just permanently on. So if I'm recording, I probably have to record at 100% light. Even with the covers closed, I can see better, which is something I just need to get used to. So have a look what's going on that side. So that's still going to come in, those lights. And then I've got a screen that I need to put in as well. Let's bring you up to the top here again. You can have a look what's going on here. You must know, there's so much settings I still have to do, so much calibration I still need to do. Pressure advance, flow control. So this is just straight out the box raw, whatever it gives. And I can tell you now, from what I can see, it doesn't look bad at all. Not bad at all. And I can already see some of the print lines. You won't see it so well on the camera. And the other thing is, if I show you like this whole printer is shaking because it's still on the swivel on the Lazy Susie. So this whole printer is shaking and the table's shaking and everything's shaking. Probably that's why the cat likes it that much. It's all very so nice and comforting for him for a little bit of the shakes. We'll let that go so long. Let me show you down here. So the other thing that I need to design, I still need to design a housing. I'm just trying to so yes. Oh no, that doesn't help me. I want table and gem. So here's the other thing that needs to go in. This is the little screen that will go on. We'll install clipper screen, and this will be mounted above the printer so that I can control the printer without having to go to the interface. It's not a must, you don't need it. It's just convenient if you want to quickly unload or load filament. Makes life a little bit easier. So that's also still going to go in. I still need to do that at some stage. So there's still quite a bit of work on the printer. The question is, how much of it am I going to stream now? Not much. What I really want to get done now is mostly I want to get the heater chamber done in that configuration so that I can show that to you, and from there I can carry on doing a lot of the stuff on the side. The Voron next to me needs a major upgrade. So maybe I'll take a week or two break, and then I'll do a Voron stream on the side when I have some time. I won't rush that stream then because I've got this printer running. I printed I just haven't ever had the opportunity really to print TPU. So this week I decided I would print some TPU. This is a TPU that I printed. The flexible block. How well you're going to see it. There you go. Not bad at all. I'm going to start playing with this as well, and then just to see if I could get my layers right. That is a 1-layer print TPU, which is, you can see, totally flexible. You can see there was difference in the layer height as I was printing, and I had to just figure out what was the best layer height so that I could print further. Yeah, that's also something I'm busy with at the moment. Let's see who's what's this? Just want to have a look at the message. What's It's amazing how busy your phone can be while the print's on. So one of the other guys down the road that's printing just received his textured plate. It looks the same as this textured plate, and he's now really to textured printing as well. That's really cool. I'm so glad, because textured printing is really so much nicer than the flat surface when you're printing a lot of objects. I'll just drop him a message here. So I'm still live on the stream and in a recording on WhatsApp as well, just so that I can show Mr. Muller we have actual liftoff. Machine is starting to print. I'm still in the live stream, so I'm actually talking to everybody while I'm talking to you. That's you got your texture bed. Enjoy. What else do I have? Oh yeah, I still have to figure out, as I said, the loom. That has to have to happen. And so, by the way, my connection at the bottom of the bed, ice cold, seems fine. Don't see any issues over there yet. Yeah, that flopping the bed is going to help me as well, because to heat up this big bed takes a lot of time. I'm looking forward to bringing in the smaller bed as well, the 300 by 300. So while that's printing then, what is the biggest challenge so far with this printer? I think for most people building this printer, the actual frame and getting it up and getting it straight, if you've got a good grade set square, right angle set square, and you've got the basic tools, that's the easy part. Yes, I've done a lot of extras, but to get the kit from RatRig with everything built in and not crimp anything and not cut anything, you could get pretty far. I actually think you could take the standard kit and almost get all the way without having to cut too many cut wires and things like that. I think your biggest challenge is your AC side of it, just to get your AC connected if you've never done that before, because you've got to feed AC into the power supply directly. You don't need the two power supplies like I've got and all the switching that I've got. You can just go straight to putting power into the power supply, and you can even feed your Raspberry Pi directly from the Octopus board. So that's easy. So really, that's up to the point where you've connected everything. The manuals are very good. I don't really see any problem with the manuals, unless you want to do certain customizations and deviations where then you need to really understand the manuals a little bit better, and where to go and where to come back to the manual. But I would say the software issue, that's probably, if you're going to go with the standard things like the Pinder probe, and you're going to put the standard heads on and that type of stuff, it all should just work. You should get to this point much faster than what I did. Again, I did so much customization, I did so many different things that it's just really it's self-inflicted for the amount of time that I've spent on this printer. I'm just seeing what what's your dad? My dad's saying here, the lighting behind the camera is a big subject. And some very good tips on the angle, the distance, and the brightness of the LEDs. Yeah, the camera behind the LEDs behind the camera, right? Just so you can see now, in this case, the lighting is sort of like a little behind and you get the shadows. And that's the one thing I'm trying to avoid, and that's why I will have lighting the full length of the bed plate, so that I can flood it in a more than 180 degree beam wise, and get as much lighting in there as possible. You're never going to get rid of the shadowing 100%. But I will have to, if I record, I will have to record with the LEDs being on 100% on, because if you put the LEDs at 90%, it's that bang bang execution of power. It's switching on and off, and it's creating oscillation, and that's what we're seeing on the camera roll. That's something where I have to think about. Again, the other thing that I was thinking about doing is, do I put a camera on the print head itself? You can put what they call a nozzle cam, which brings it a lot closer. I think it's a bit of an overkill. I don't really think it's going to be necessary, but I need to buy a camera which is going to sit inside the housing, and because the housing will be at the chamber will be at 60 degrees, it's going to have to be a little bit of an industrial printer, industrial camera, which can handle the higher heat, because it gets hot inside. It's hot for the camera. I've used these Wise cams, quite a few. I've got quite a few of these Wise cams, and they don't like being in the top of the chamber pointing down, because the heat at the top of the chamber is much higher. It gets up to like 70-75 degrees inside there. So yeah, definitely I'm gonna have to buy a better quality camera to be able to do video. But again, I think you need the camera in there. Question again is how wide a lens do you go? How high, how low do you go with the camera? I'll have to play with different cameras and speeds and things like that. There's a software called Octoprint. Octoprint lets me be able to see the camera that's connected to the Raspberry Pi directly. I can stream that to my phone anywhere, because I can connect to the actual software, and it's pretty secure. I pay for the subscription, so that's something that also will come along at some stage. I'm just thinking maybe next week I will, prior to the stream, see if I can time it right and print something a little bit bigger. It feels so wrong printing this little cube in this massive, in the middle of this massive bed. But I really want to just get a baseline of what can you expect out of the box. I think it's important that we see that. We are obviously going for 2.5 hours already, but this video might be it's well worth it. It's well worth getting the piece of plastic out. And if you're watching this in the future, don't forget to like and subscribe. I will do more. I'm not sitting around like this. I will do more videos, posting and building, and trying to share as much as I can from my practical experience. I will continue to try and put my prints, my designs, that I have onto printables, and so that people can download them there. And yeah, soon I'll be. My aim is to also, for anybody in, well, it's not anybody only in the UAE region, but further than that region as well. I want to offer printing the RatRig parts, the printed parts, as a service, because I saw what I got and I was not happy with that. So I know I can deliver a lot better quality product, and so I'll be offering that service as well, printing parts for people. Now it will be easier if the people live in the UAE, but most guys ship across the world. I will ship. If the person's willing to pay and he lives in the South Pole, I'll ship it to him. We'll see how the shipping costs work, how to go about that. But that's also there. I can also do because I've got a Voron, I can also print Voron parts, you know, and I can print them on the RatRig. It's not about a Voron versus RatRig competition over here. I like both brands. I love both printers. I also like the Bamboo Labs printers, and I like the Prusa printers. Can't say I like too many of the other ones. Maybe the Raise 3Ds, but it's not about I see one better than the other. And I went with the RatRig because I wanted the bigger frame. I wanted the bigger bed. It's the only 500 by 500 by 500 can I say consumer grade printer that you can buy in a kit format. If you want to build a RatRig 500 by 500, then you have to custom everything. There's no 500 by 500. Well, and when I stand under correction when I last looked, but this is the RatRig were the only ones that actually gave us a full kit complete. So yeah, you've got to decide what you want. And if you don't need a 500 by 500, I think RatRig, Voron are doing a 350 by 350. Kit, and there's lots of different kits, and obviously you must shop around. If you're going to buy some of the China-based kits, they're a bit cheaper. Some of them are good, some of them are not so good, but very acceptable. If you're going to buy a Aldio Voron kit, you'll see the quality of the parts is quite a bit better. Let's have a look on, yeah, see my lighting over there is not so great, and I think it's got something to do with this light at the back here. Let me just drop that light a little bit. I wonder if it helps. Yeah, that's a little bit better. That light was creating a contrast issue. You can see how fast that head's moving now. And this is normal speed, guys. we haven't put on, and you can go higher speeds if you really tune it and you put your voltages up and stuff. You can go much higher. Let's have a look at, while that's busy, let's have a look at the main screen. Just show you a bit of what's going on in there. So yeah, it's maintaining your extruder. Oh, we haven't even done PID tuning. I should have done that. I should have done that first. Any case, they have rough PID values already in, but I'll have to do PID. So PID basically it heats your bed and your nozzle, and it heats it up and lets it cool down. It heats it up and lets it cool down, and it calculates how much it needs to heat, because there's always overrun. You heat and you overrun, and then you sag and you drop out before you put your heater on. So it tries to keep the heat as constant as possible, right? Meaning this line over here, which is running over here, it'll try and keep that line as consistent as possible. Okay, and that one there as well, as consistent as possible. So PID tuning does that logic and calculation as to how much your printer head needs to be off and how much it needs to be on. Yeah, you can see some of the machine's accelerations. You can see with the speeds that we're hitting. I see every now and again we hit a 200. The flow ratios that we got, it gives you your total time of the print, how long it estimates before it's going to be finished, which seems to be another 5 or 6 minutes, although that estimate and that estimate is different. So yeah, this one says the file says about 8 minutes, and the filament says about 9 minutes to go. So we're almost there, and we'll be finished our stream before the 3-hour mark. Yeah, we can see our fans are running nice and clean. You can see the Raspberry Pi is nice and ice cold, doing very well. The Octopus mainboard temperature is doing very well, nice and cool. So my fans are really doing well. The beacon coil, well, that's inside the machine. There's not much we can do about that. Although I think the fan blowing on the nozzle will probably cool that down, hopefully a little bit. Toolboard, yep, it's gonna get hot. These two items, this toolboard and the beacon coil, are they're gonna jump up quite a bit as soon as the enclosure's closed up and running. Yeah, from there's not much we really see in terms of live data. On the print shop itself. We could have a look at, so it loaded this, when it ran a RatOS heat as the mesh. I picked up this mesh quickly. You can see there the range is slightly different again. I got a funny feeling I've got something to do with the frame. I'm going to have to read up. So yeah, Julia, for you, there's this video. Let me try and get it open on one of my other screens while I'll just take this onto this side, and I'll see if I can get this video. Later.
Hi YouTube, welcome to my new channel 3D Printers and
videos. This one.
Pause. This.
So I'll bring this onto the screen. This video from this 3D printers and a whiteboard. RatRig V-Core, how to get a square frame. I think it's well worth a watch. I'm busy watching that, and he talks a lot about the geometry, goes very much into detail as to how your bed and how your frame can affect your bed's meshing. So I think it's well worth watching this video if you're still online. Google go to YouTube, how to get a square frame RatRig V-Core3, this guy, and have a look at it. Let's go back to, oh, not that one, sorry, that one. Let me show you a bit with this camera. There we are. There we go. That cube is going to be amazing. I don't even know if I have to tune the machine. Just leave it like it is. Really, really cool. In the background you'll see, I can't see if I can show you there. There's the other printer that I use. It's what I call my not so creality. And it really does well as well. It's a good machine. It's a good machine because it's now been upgraded to an amazing machine. It's running full clipper as well. It's got full linear rails. It used to come with V wheels. It's got a duet board in it. I burnt out a lot of it trying to get ready for this printer because I had it in the tent and I overheated it and it shorted out, and it cost me a lot of time and a lot of money and a lot of effort to get it back up and running. So that machine will be now dedicated for PLA, PETG and TPU printing, but I'm going to try and focus mostly with TPU printing because I think I've got a couple of things I need to try and run through on that. I don't know how much you can hear this printer through the microphone. You know, it's not incredibly loud, but I think the microphone's got active noise cancelling, so you might not hear the printer itself. You might just be hearing the music. There we know, we're not far from the top layer. Let me have a look on screen what I see. Yeah, I can see it's starting to do the top layers. We're at 97% with about a minute to go. Sometimes you can hear the printer. It's actually not loud for such a big printer. And if you think I'm going to put it inside and close it up, probably the worst thing on most printers is the fans, because that fan is running flat out. And those two fans on the back, the blower fans, are pumping a lot of air out. 99, 12 seconds, 10 seconds. And when we get that down, we can bring it down, yeah. And we'll bring it with light. See if we can. There we go. First print job ever well, barring the first layer. Give it a second just to cool off before I grab it. Coming back to the screen now, you'll see, we'll give you the status. It used 3.72 meters of filament. The slicer said it would take 34 minutes. The print estimation, the print took about 38 minutes, and the total time with everything inclusive took about 43 minutes. So it gives you a good amount of stats. He has this measure XY core belt tensioner that I was talking about. I still need to do that. I just still need to do the input shaper graphs. So there's a couple of those things over there. Let's grab the cube. Let's see what it looks like. One or two little strings. Okay, so let's be critical on the first cube. And which way are we going to go? Let's go with, we want the table and the main. Alright, so little cube, and I'll try and hold it like that. See if we can get it to focus. Sure. Can't get it to focus. I don't like that. Come on. It's like autofocus just does not want to work. Let me just click on this. Properties. Configure video. Camera. Is on autofocus. Okay. For some reason I can't get it to focus that well, but any guess. So you'll see that on that edge there, you've got a lot of resonance, and that's where the input shaper comes in because it's printing so fast. We have to get rid of that resonance a little bit, right? Turning it to the next face. On that face we don't have so much resonance, but you can see the whiskers came out pretty neatly, and the whole rat face is fine. We've got a bit of pressure advance issues, but that's also looking pretty good for initial. Y the same, X the same, yeah. So in general, for printing at that speed with absolutely zero settings, I can tell you now that's actually quite a good print in one way. We need to definitely do a couple of changes. In the bridging, I don't know if you're going to be able to see the bridging inside. Yeah, it's a bit difficult to show the bridging. The bridging inside also looks pretty neat. Yeah, hooray! Done. First print done. Shockingly, let's say, embarrassing for such a small block on such a big bed, but we had to print something. So I thank you very much for your time tonight, and for those that have been online and have been commenting, I appreciate it, and I do hope that you've had a good watch and a good time watching this video, because it's the one that we've been waiting for such a long time, and at least most things went right tonight for a change. As I said, probably my next stream is heated bed, heated chamber, and put the panels on. Get that done. The lights maybe, if we can, we'll see. And that's it. Then we start printing with ASA, which needs the heated chamber. And I'll print my camping requirement first, so that I can get that going. And yeah, awesome. So thank you very much. Hope you have a good week, good weekend, good evening, and I will see you next time. Don't forget to like and subscribe, and please throw as many comments as you need into the comment section afterwards, or ask questions later on in the week. Have a good day. Cheers.